Okay, this is WeBWork 2.1, and we're finding the area first. So we need to first, we see that we're over the interval 0 to pi over 2, but we need to find when both functions intersect. So first, we're going to make note that area is top minus bottom, and defined where they intersect, we need to let f of x equal to g of x. All right, so we have cosine of x equal to sine of x, cosine of x. Using our identity, we know that sine of x can just be square root of 1 minus cosine of x, or cosine squared of x. Perfect. All right, square either side gives us this. Now we just solve for this. Perfect. And we get rid of the 2. Cancels out. Cosine square root of 1/2. And then square root gives us this. Therefore, cosine of x and sine of x intersect at x equals pi over 4. So now we know that we can split our integral into 2 separate ones. So we have area equal to integral of 0 pi over 4 cosine of x minus sine of x, top minus bottom, dx plus integral of pi over 4 pi over 2, again top minus bottom, this time sine being top, cosine being bottom. Perfect. Now we just take the integral of this, and very simple, we know the integral of cosine is just positive sine, and the integral of sine is just negative cosine. So here we go. Perfect. That's our first integral. Second integral, sine, negative cosine once again. And then negative cosine is just going to still be negative sine. Perfect. Now we're just going to plug in our bounds. And that'll give us sine of pi over 4 plus cosine pi over 4. And sine of 0 is just 0. And then cosine of 0 is just 1. So it's 1. Okay. And then same thing here. Just plug in our bounds of integration. Oh, sorry, it'd be negative 1 because we're subtracting. And now we have, again, negative cosine. It's got a little of a tight squeeze here. Minus sine pi over 4 as well. Perfect. Okay. Now when we plug this all in, this is just going to evaluate at negative square root of 2 minus 1 plus negative 1 plus square root of 2, which makes sense. It's because they're just alternating, which is just going to give us negative 2 and then 2 square root of 2. And that is our answer to the problem number 1.